I am Paul. Now I am demonstrate about how fast come first serve process scheduling works. In operating system, basically we learn four popular operating system process scheduling technique. That is, first come, first served, FCFS. Shortest job first, SJF. Priority, and round robin, algorithm. End of this video you will learn how fast come first serve process scheduling works. This is the simple question of a fast come first serve algorithm. Here there are three processes and each process has burst time. P1 for 24 microsecond, P2 for 3 microsecond, and same P3 for 3 microsecond. Now we will calculate average waiting time and average turnaround time. At first we draw a Gantt chart. P1 has burst time 24 microsecond, P2 and P3 has 3 microsecond each. So that the waiting time for P1 is 0 millisecond, P2 for 24 millisecond and P3 for 27 millisecond. For that average waiting time is 0 plus 24 plus 27, slash 3 equals 17, 3 for we have 3 process, P1, P2, and P3. Average turnaround time, 24 plus 27 plus 30, slash 3 equals 27, 3 for we have 3 process and time, P1, P2, and P3. One thing you should be careful, working on this scheduling algorithm, you might not be schedule all the processes continuously, there might be some gaps in the Gantt chart. For example, see this, let's us say process are like this. Process number, arrival time, burst time, process P1, process P2, process P3, and their arrival time is 0 and burst time is 2. Similar to process 2, arrival time is 3 and burst time is 1 and the arrival time is 5, and the burst time is 6. What happens is, you pick the first one, to get execute the first one, so which is going to have P1, and started with 0, and burst time is 2, so finish in 2 microsecond. And then what happens is, after 2 microsecond it will check which is next one arrived after. To look at it, the first one arrived has 0, but the second one is not arrived yet, no other process has arrived, it has to wait for time 3. For 2 to 3 we are simply wait, what is next one process P2, P2 is available here, burst time for P2 is 1 unit. It will be finished by 4, and at a time for 1 and 2 is over and process 3 has not come, so it will wait. So that there are some gaps in Gantt chart. That is simply CPU is idle, not work any work, you cannot write P1, P2, P3 because they are not available at write. P3 is finish it in 11 microsecond. What is total schedule? It start with 0 microsecond and finish 11 microsecond. But it wait 2 microsecond in middle. Just be careful that whenever kept in nest process just check it available or not. Now we check completion time, for P1 is 2, P2 is 4, and P3 is 11. So that the turnaround time is completion time minus arrival time, so P1 is 2, for P2 is 1 and P3 here it is 6. And then what is the waiting time? Very interesting, check this. Waiting time is turnaround time minus burst time, that is P1 0, for P2 0 and P3 also 0, waiting time all the process 0. Because, no process actually waiting for the CPU, in fact CPU waiting for the process. Now how to implement this? FCFS. Simply use data structure using implementing in queue. So you have a maintain this queue, as process arrived put them into the queue. That about the time complexity, from the queue actually remove, add one at each process and remove each process. Every process enter the queue once, which is going to constant time, and time complexity of algorithm is order of m, where m is the number of processes.